Good afternoon. My name is Vadim. I'm a Tokyo Tech student. Today, I would like to present my research that is called the identification of urban activity centers. In this research, we try to investigate how urban activity centers, UAC, can be identified from available data in Tokyo. Let me begin with a short introduction about the urban spatial structure and urban centers. Since the second half of the 20th century, there is a trend to characterize the urban spatial structure through the analysis of urban centers. For sustainable urban management and transportation planning, it's important to understand where in cities the most economic, social, and other activities take place. So the detection and delimitation of urban centers became the major issue in urban studies. Originally, urban centers were studied from the perspective of the distribution of workplaces in a city. An example of such centers are central business districts. Later on, urban centers started to be considered as the multifunctional centers, and one of the most recent and advanced methods to identify such centers are urban activity centers developed by me. In most general terms, UAC are areas of a city where the concentration of outside-of-home urban activities is significantly higher than in surrounding areas, irrespective of their location in a city. The feature of UAC-like method is that they allow to identify centers attracting people on different scales, while traditional methods allow to detect only points of the highest activity in the whole city. UAC thus are believed to be a more effective and suitable option for targeting city-level planning measures precisely, since they represent most attraction points of a city, irrespective of whether they are located in the city center or in peripheries. The problem of the identification of urban centers, typical for the previous works, is that given the lack of data representing urban activities directly, scholars had to use indicators extracted from sources such as social media data, cell phone data, data on the area or revenue of businesses, satellite images, and so on. However, the relation of all this data to urban activity is unclear. The correlation level may vary significantly. For this work, we created the indicator representing the spatial distribution of urban activities directly. We extracted it from the results of the six-person trip survey. This indicator of urban activity, called the PT indicator, represents the number of people visiting a certain place for purposes that are related to outside-of-home urban activities, such as work, eating out, leisure, shopping, and so on. You can see the list of such activities in the right part of this slide. Using this indicator, we identify UAC by means of the UAC identification algorithm developed by me. We call it the UAC pipeline. In this pipeline, the spatial autoregression is used to model the distribution of a certain indicator of urban activity based on its values in neighboring cells, which is called local trend, and the global activity trend, which is the fact that urban activity tends to decrease from the city center to peripheries. The significant positive residuals from such model reveal cells where the urban activity is significantly higher than in its surroundings, irrespective of the distance to the city center, so they correspond to our definition of urban activity centers. The UAC identified by processing PT indicators through this algorithm may be applied for targeting the most active areas of the city and applying the corresponding measures and practices for sustainable urban planning. That's it for my presentation. Thank you for your attention, and here is the list of references I used for this presentation.